It's time for Maths with Mr. Thomas.
Ahoy there! Here is chapter 10, lesson number 5, intersection of a line and a circle. What I mean by that then is it's where a line and a circle meet. And if you think about that, there are three possibilities. Either you could have the line going pew and passing right through the circle, so it's going to touch in two places, so 2 points of intersection. You could also have it where it's going ba-doing, and it is going to hit the circle just in one place, so there will be 1 point of intersection. Or you could have it looking like this, so there will be no points of intersection. Does this remind anybody of anything? Valley, what does it remind you of? Yeah, quadratics. If you think back to quadratics, remember your quadratic could either touch the x-axis in two places, it could touch just in one place, so it's just touching and no more, or it may not cross over the x-axis at all. So it's very similar to this, and it does link in. What did you use to work out if a quadratic touches the x-axis or not? What did you use for that? Yeah, the discriminant. Good. So it's the same with the circle. The discriminant can be used to find out the number of points of intersection. So if there are 2 points of intersection, then it means that b squared minus 4ac must be bigger than 0. If there is just 1 point of intersection, it means that b squared minus 4ac equals 0. And if the line does not touch the circle at all, then b squared minus 4ac will be less than 0. Obviously for this though, we are needing a quadratic in order to use the discriminant. And to form the quadratic, what you do is this. So to find out if a line meets the circle, we do need our quadratic. And to get that, first of all, you would substitute one equation into the other. So you'll have the equation of the line and the equation of the circle. So sub one equation into the other. Then what you can do is you can multiply out brackets and so on, take everything to one side, and you will then rearrange into the form ax squared plus bx plus c equals 0. So you have that quadratic. And after you have your quadratic, you can then use the discriminant to find out the number of points of intersection. Oh, yes. So let's move on and do some examples with that. So example number 1, find the points of intersection of the line 5y minus x plus 7 equals 0 and the circle x squared plus y squared plus 2x minus 2y minus 11 equals 0. So remember the steps from the last page. The first thing you want to do is to sub one equation into the other. So to do this, how would you go about doing it? Help us out, Ziad. Good. If you look at this first equation, the 5y minus x plus 7 equals 0, well, you could rewrite that. So if we rewrite that equation, well, if we add x to both sides, or move the x over to this side, then x will be equal to 5y plus 7. So if x was then equal to 5y plus 7, well, we could take that and sub it into the other equation. So we're replacing the x with 5y plus 7. So let's do that. Substitute x equals 5y plus 7 into the equation of the circle. So all we've done is rearranged this, and we're subbing it into the other equation. So we know what x is equal to. So instead of x squared, we'll have 5y plus 7 all squared. Then we've got plus y squared, then plus 2 times the 5y plus 7, then take away 2y, take away 11 equals 0. From there, multiply out the brackets. So 5y plus 7 times 5y plus 7, multiply that out, you get 25y squared plus 70y plus 49. You've still got plus y squared, multiply out this bracket as well, and obviously these terms will stay as they are. From there, you can gather all the like terms together. So we've got y squared. So 26y squared. We've got a y term, we'd have 78 for y, and we've got a plus 52. From there, we want to find out the point of intersection. So how would we do that? We need to find the value of y. And to find the value of y, you would factorize. Woo! So factorize, you take out 26 as the highest common factor. Then you were left with 26 bracket y squared plus 3y plus 2. And you can also factorize that. If you do that, you'll end up with 26 bracket y plus 2, y plus 1. Meaning then that if that equals 0, then the y plus 2 would equal 0, meaning y would equal negative 2. And also you could have the y plus 1 equal 0, meaning y would equal negative 1. So there are two possible values there for y. You want to find the points of intersection. So because it's points, you are going to get two values for y. And if you do get these two values, you obviously need to find the x coordinate as well. How would you get the x value? Yeah, substitution. You can just sub it into this equation here. So you know that x is equal to 5y plus 7. So if you sub these two values in for y, you can find out the x value. So using x equals 5y plus 7, when y equals, let's go with the negative 2. First of all, just replace y with negative 2. So we'd have 5 times negative 2 plus 7, which will give us negative 10 add 7, which is negative 3. Meaning then the x coordinate is negative 3 when the y coordinate is negative 2. Giving you the point, negative 3, negative 2. Do the same thing with the other y value. So when y equals a negative 1, x would equal, replace y then with negative 1. So you'd have 5 times negative 1 add 7, which is negative 5 add 7, which is 2. So the x coordinate would be 2, when y would be negative 1. So that would be your other coordinate there. So find the points of intersection. Well, these are the 2 points of intersection. Example 2. Prove that 3x plus 2y equals 6 is a tangent to the circle x squared plus y squared plus 2x plus 4y, and take away 8 equals 0, and find the point of contact. So the first thing you want to do to prove it is a tangent, remember you rearrange one of the equations and then you can sub that into the other. You rearrange it in order to get the equation into the form of x equals or y equals. You cannot just sub it in the way it is. It's always best to rearrange the equation of the straight line. That's far easier to get into the form of x equals or y equals than the equation of the circle. So let's take the 3x plus 2y equals 6. And rearrange it. If you rearrange it, let's take it into the form of y equals. So to do that, you would subtract 3x from both sides. So 2y would equal 6, take away 3x, and then you can half every term. So if you half the 2y, you would end up with y, and if you half the 6 take away 3x, well, I've just put in the half at the start. So that is us rearranging the equation of the straight line. From there, now we know what y on its own is equal to, we can replace y in the circle equation. So we can replace the y squared with a half 6 take away 3x squared. We can replace the 4 times y with 4 times this again. So we are going to substitute the y equals 1/2 bracket 6 take away 3x into the equation of the circle. So doing that then, you will end up with this. We'd have x squared, that stays as it is, plus the half 6 take away 3x all squared, plus 2x plus 4 times the half 6 take away 3x, and then the take away 8 would stay. From there, you're probably wanting to multiply out the brackets. So doing that, x squared would stay as it is. If we square the terms in the bracket here, well, you're squaring the half and you're also squaring that 6 take away 3x. So really you're squaring a half, so a half times a half is a quarter, and you're also squaring the 6 take away 3x. Just writing it out like that first of all. 2x would stay as it is, and then it would be plus, well, you could just do 4 times a half first of all. So 4 times a half is 2, so it's really 2 times the 6 take away 3x. Take away 8 stays, and that equals 0. So that is really multiplying out this square bracket and multiplying out this bracket here. Obviously, you do still have some brackets, but what you may wish to do, you've got this fraction here, and remember it's a bit more complicated when you have fractions, so to get rid of the fraction, to get rid of this quarter, or divide by 4, is to multiply every single term by 4. It just eliminates any fractions that you have. You don't have to do that, but it may make it a bit simpler. So multiply every single term by 4 to eliminate the fraction. That will then give you, instead of x squared, you'd have 4x squared. Multiply this by 4, it would cancel out the divide by 4. In other words, it cancels the fraction. So you still have 6 take away 3x all squared, or in other words, 6 take 3x times 6 take 3x. This, if you times it by 4, would become 8x. The 2 bracket 6 take away 3x would become 8 bracket 6 take away 3x, because we're timesing that by 4. So 4 times 2 is 8. And the 8 times that by 4, and you get the 32. From there, multiply out these brackets. So if you do that, this is what you will end up with. And again, you will gather your like terms. So gather the like terms. X squared, we'd have 13 of them. Then we'd have take away 52x, and we'd also have a plus 52 equals 0. So going back to the question, prove that that line is a tangent to the circle and find the point of contact. Well, what we've done first of all is we've substituted the equation of the line into the circle. So we've done that. Now we need to prove that that is a tangent. And to prove it is a tangent, that is when you go off and you think about the discriminant. So we had that 13x squared take away 52x plus 52 equals 0. The discriminant, remember, you need the values of a, b and c. In other words, the coefficient of x squared, x, and this number that's on its own. So we've got 13, negative 52 and 52. Work out b squared minus 4ac. If you work that out, you'd have negative 52 squared, take away 4 times 13 times 52. It gives us 2,704, take away 2,704, which is 0. And if the discriminant equals 0, what does that mean? Brilliant, there is just one point of contact. So, since b squared minus 4ac equals 0, the line is a tangent to the circle. That is one way of doing this. Okay, so you're going through it and you can use the discriminant. Since b squared minus 4ac is 0, the line is a tangent to the circle. If you're asked to prove it, that would be fine. We've done that. What you then have to do to find the point of contact is you would have to find the value of x. So then you would have to factorize. So we had 13x squared take away 52x plus 52 equals 0. You could take out 13 as a common factor. So take out 13, you're left with x squared take 4x plus 4 equals 0. Meaning then you can now factorize what's in the brackets. So you'd have 13 bracket x take 2 bracket x take 2. Equals 0. And if you look here, we've got our 13 times and we've got x take 2, which means then that x take 2 would equal 0, so x equals 2. And really the same thing again, would also have another x equals 2. So really, the only value you have is x equals 2. So you could also, if you didn't go down the discriminant route, you could also just have factorized, but then once you get to the end here for factorizing, you would have to say that since there is only one point of contact, when x equals 2, the line is a tangent to the circle. Remember, a tangent touches the circle just in one place, at one point, and the only point we have is x equals 2. So for this, you can either go down the route of the discriminant, but then you'd have to factorize anyway to find x, or you could just factorize to begin with and then say that there is just one point of contact. So if you went down the discriminant route, you'd have to say that since b squared minus 4ac equals 0, the line's a tangent to the circle, and you wouldn't need to write that line. If you just went down the factorizing line, then you'd have to write this because that's you proving it. So there are two ways to do that. Obviously though, the point of contact, once you know that x equals 2, you can use that equation that you rearranged, y equals a half bracket 6 take away 3x, and we can sub in that value, x equals 2. Subbing it in then, we'd have a half times 6 take away, that becomes 6, so it's a half of 0, which is 0, meaning then the point of contact is going to be 2, 0. Let's move on. Example number 3. Show that the equation of the tangent at A, which is 8, negative 6, to the circle x squared plus y squared plus 20y plus 20 equals 0 is y equals 10 take away 2x. And then part B, prove that this line is also a tangent to this circle x squared plus y squared is 20 and find the point of contact. So for this, we're wanting to show that the equation of the tangent at A to the circle is y equals 10 take away 2x. So really what they're doing is they're giving you the answer here. So that is your answer and you are asked to prove that. This part A question is the exact same as what we did in the last lesson. So to do that, you would have to first of all think, right, well, what's the center of this circle? It is in the general form, so you have the coefficient of x and change the sign to get the x coordinate of the center. Term, so the coefficient term, so the coefficient 0, you still have 0, you still have 0. For the y term, well, the coefficient is 20. That is the center of that. That is the center of that. That is the center of that. That is the center of that circle. Using this diagram to help explain it, your jotters. So you have one. Basically, you have one of these circles. Woo! It's 10. It's 10. It's telling you that this point A at 8 and negative 6 is circle. So you want to find the equation. Remember, again, the same as last lesson, go back if you're unsure. But the way you get that is to get the gradient of the radius here between these 2 points. So the gradient between A and the centre would be y2 take y1 over x2 take x1. So do negative 10 take away negative 6 over 0 take away 8. That'll give me negative 4 over negative 8. Cancel the negatives, and that would give 1/2. So you know the gradient of the radius here would be 1/2. You want the gradient of the tangent though. Sahana! Glad to see you're awake. What is that gradient? Brilliant, well done. Negative 2. Because, good, all you want to do is you flip the gradient, change the sign because it's the perpendicular gradient. The tangent and the radius meet at right angles. So this in here will be a right angle. From there, we've got the gradient, you know it's negative 2. You know the point is 8 to negative 6, so you can use the equation y minus b equals m bracket x minus a, using the point of contact and that gradient. So you'd have y take away negative 6 equals negative 2 bracket x take away 8, which would become y add 6 is negative 2x plus 18, and subtract 6 from both sides, you'd have y equals negative 2x plus 10. Obviously though, we are asked to prove the equation is y equals 10 take away 2x, so you may wish to just write it in that form to finish off. Y equals 10 take away 2x. For part B, prove that this line is also a tangent to this circle. X squared plus y squared equals 20. So now we're proving that this line is a tangent. How do you go about doing that? What would you do? Anybody help me out? Iman? Brilliant, well done. It's just the same as the other examples. You're just wanting to arrange this into the form of x equals or y equals, which you have, and then you can sub that into the equation of the circle. You'll then get your quadratic, and you could use the discriminant to prove it. So let's do that. So solution B. Substitute y equals 10 take away 2x. Remember, that's the equation of the tangent. Sub that into the equation of the circle. X squared plus y squared equals 20. So you would have x squared plus 10 minus 2x all squared equals 20. Multiply with the brackets, and x squared plus 100, take away 40x plus 4x squared equals 20. Gather your like terms. So moving the 20 over to the other side, or subtracting 20, and if you gather, you'd have 5x squared minus 40x plus 80 equals 0. So that is us substituting one equation into the other. We've now got our quadratic, and Iman, remind us what do you use? Good, well done, the discriminant. So from here, use a discriminant on this equation, this quadratic that we came up with. So write down the coefficients of x squared, x, and your number that's on its own. So we've got 5, we've got negative 40, and we have 80. And work out the value of b squared minus 4ac. Subbing the values in, you'd have negative 40 squared minus 4 times 5 times 80. Which will give us 1,600, take away 1,600, which is obviously 0. And what does that mean then? Well, it means that since b squared minus 4ac equals 0, the line is a tangent to the circle. Remember, you could also have just factorised to begin with. So you could have factorised that, but we'd have to do that anyway with the discriminant. So we are asked in the question to find the point of contact. So going back to this, you have to factorise this to find the value of x. So 5x squared, take away 40x plus 80 equals 0. Take out the highest common factor, which would be 5. So we'd have 5 bracket x squared, take away 8x plus 16 equals 0. Factorise this bit in the brackets, and we've got 5 bracket x minus 4x minus 4. Meaning then, the only value of x is going to be 4. Because we'd have x equals 4 here and x equals 4 here. So we'd really have x equals 4 twice. And again, if you didn't go down the discriminant route, you would have to say that since there is only one point of contact, the line is a tangent to the circle. From there, now we know the value of x. How do we work out the y value? Well, if you look back to that part A, you had the equation y equals 10 take away 2x. So you can sub in the x value to find y. Therefore, the point of contact would be 4, 2. Example 4. Find the values of m for y equals mx to be a tangent to the circle x squared plus y squared minus 4x minus 2y plus 4 equals 0. So we want to find the values of m for which this obviously straight line y equals mx is going to be a tangent. And now remember, in order to prove if a line is a tangent, you substitute one equation into the other to form a quadratic. In order to then be a tangent, b squared minus 4ac must be equal to 0. So here, obviously, y equals mx, so we can replace y in our circle equation with mx. So let's do that. Y equals mx, we'll replace then the y, so we'd have x squared plus mx squared. Take away 4x, take away 2 times mx plus 4 equals 0. Multiply out these brackets then, so we've got mx times mx, so squaring the m, we're squaring the x. So we'd have x squared plus m squared x squared, take away 4x, take away 2mx plus 4 equals 0. Now you know we've got a quadratic, but we need it in the form of ax squared plus bx plus c. So in order to get it in that form, what we need to do is gather our x squared terms first of all together. So to do that, we can take out x squared as a common factor, because if you think about it, x squared on its own means 1x squared. So taking x squared out as a common factor here, we would then have x squared bracket 1 plus m squared. Also, we've got an x term here and an x term here. We want to gather our x terms, so let's take out x as a common factor. To make this easier to get it in the form of ax squared plus bx plus c, I'm going to take out the plus x as a common factor. Then think, what would I have to multiply plus x by to get negative 4x? Well, to multiply that by negative 4. And what would you multiply plus x by to get to negative 2mx? Well, it'd be multiplying that by negative 2m. And obviously the plus 4 would stay as plus 4, and that still equals 0. So we've now got it in the form, we're wanting ax squared plus bx plus c equals 0. So just rearrange it slightly. So we've got our ax squared plus bx plus c equals 0. And then we've got the values of a, b, and c. It's the coefficients of x squared, x, and the number that's on its own. Now from there, just remember that for tangency, in order to be a tangent, there can only be one point of contact, so b squared minus 4ac must be equal to 0. Going over the page then, this is just what we had. So if you have then b squared minus 4ac equals 0, well, you can then sub in the values for a, b, and c. So b squared will be negative 4 take away 2m all squared. Take away 4 times a, which is 1 add m squared, times c, which is 4. Multiply out the brackets then, we'd have our negative 4 take away 2m times negative 4 take away 2m. Square that then, will give us 16 plus 8m plus 8m plus 4m squared. Here you would have negative 4 times 4 would give us a negative 16. Times that by 1, we've got negative 16. And negative 4 times 4 is 16 again. Times that by m squared, you get negative 16m squared. Gather the like terms, so you would have 16 take away 16, which would disappear, and we'd have 8m add 8m, which is 16m, and 4m squared take away 16m squared is negative 12m squared. To find the value of m, what would you do next? Good, factorise. So factorising, you can take out 4m as the highest common factor, so we have 4m bracket 4 take away 3m equals 0. And to solve that to find the value of m, well, if 4m was equal to 0, well, m would be equal to 0 as well. And if 4 take away 3m was equal to 0, well, you can add 3m to both sides, so 3m would equal 4, and then m would be equal to 4 over 3. For this, we are getting two possible values for m. We are getting m equals 0 and m equals 4 over 3. Thinking back to the original question, find the values of m for which y equals mx is a tangent to this circle. So because we've got two possible values of m, we would have y equals 0x. So if you think about your x and your y axis, let's just draw it very, very roughly. If you had an x and a y axis, we'd have y equals 0x. So in other words, you would just have a flat line, just in other words, your x-axis, and you would have y equals 4/3 x. So you would have a line that's looking something like that. It means both of those lines would be a tangent to the circle. So you would have a circle that would be drawn in, and this line y equals 0x would be a tangent. It's going to touch just in one place, and the y equals 4/3 x would also be a tangent. That would also touch just in one place. So it's giving us two different lines, and that's how you do that one. Give these questions a shot. Maths in Action Higher, page 176 onwards. It's exercise 5A, and you can try 5B as well. Woo! Don't say I'm not good to you. Try these. Any problems, just let me know. Good luck. Bye!